Welcome to this new section in this advanced predictive analytics course. Here we will be talking about working with features. These are techniques that will allow us to improve our predictive analytics models in two ways. We can improve our models in terms of performance, of the performance metrics of our models, or we can view this as improving in predictive power. And the second way in which we can improve our models is in understanding. We can get a better understanding of the relationship between the features and the target, the variable that we are trying to predict. So let's see what we are going to do in this section. In the first video, we will talk about feature selection methods. And these are methods for selecting features that are likely to help with prediction. In the second video, we will talk about dimensionality reduction. Dimensionality reduction are techniques to reduce the number of features that are used in the model. Sometimes we can simplify our model by including less features, and dimensionality reduction techniques are the ones that are used for that purpose. The most widely used dimensionality reduction technique is principal component analysis, or PCA, and in the second video we will do an example of that. In the third video we will do what is known as feature engineering, and we will be creating new features from the existing ones that we have in our datasets. And finally, in the last video, we will try to improve our models with feature engineering. And we can improve the model in two ways. We can get better performance, better predictive power of our model, or we can get more understanding, we can gain insight about our dataset and the relationship between features and targets. So these are very useful techniques for building and understanding better your predictive analytics models. Okay, this is the first video of this section, feature selection methods. This is the plan for this video. First, we will talk about feature selection. Then we will discuss the three methods for feature selection. The first one is very simple. It works with dummy features, and we can identify and remove dummy features with low variance. The second method is identifying important features by performing statistical tests. And the last one that we will discuss is recursive feature elimination. Okay, so when building predictive analytics models, most of the times some features won't be related with the target. So they, by definition, can't help in prediction. Now, the problem is that including irrelevant features in the model can introduce noise and add bias to the model. So feature selection techniques are a set of techniques to select features that are most relevant and useful for our model, in the sense that they will help either with prediction or with understanding of our model. Okay, so the first one, the first technique of feature selection that we will talk about is removing dummy features with low variance. So as you know, the only transformation that we have been applying so far to our features is to transform the categorical features using the one-hot encoding technique. So if we take one categorical feature and use the one-hot encoding technique, we get a set of dummy features. We get a set of dummy features, and then we can examine if these features have variability, or maybe they don't have variability. So features with very low variance are likely to have little impact on prediction. Now, why is that? Imagine that you have a data set where you have a gender feature, and that 98% of the observations correspond to just one gender, just to female. So it is very likely that this column, this feature won't have any impact on prediction, because all of the cases are just of one of a single category. So there is not enough variability. So these cases become like candidates for elimination, and such features should be examined more carefully. Now, you can take the following approach. You can remove all dummy features that are either 0 or 1 in more than X% of the samples. Or what you can do is to establish a minimum threshold for the variance of such features. Now, the variance of such features can be obtained with this formula, P times 1 minus P, where P is the number or the proportion of ones in your dummy features. We will see how this works in the notebook. The second way is to identify important features statistically. And this method is to make use of some statistical tests for identifying and selecting relevant features. So, for example, for classification tasks, we can use an ANOVA F statistic to evaluate the relationship between numerical features and the target, which will be a categorical feature because this is an example of a classic classification task. Or to evaluate the statistical relationship between a categorical feature and the target, we will use the chi-square test to evaluate such relationship. And in Scikit-Learn, we can use the select k-best object, and we will see how to use that object in the notebook. Okay, the third approach for identifying important features and removing the ones that we don't that we think are not important for our model is called recursive feature elimination, or RFE. So RFE is something that also can be applied in Scikit-Learn, and we can use this technique with models that calculate coefficients like linear or logistic regression, or models that calculate something that is called feature importance, as we saw in the first video of this course. Like Random Forest provides us with this feature importance metric. So for models that don't calculate these things, either coefficients or feature importances, this method cannot be used. For example, for KNN models, you cannot use this recursive feature elimination because this works by the first step in using this technique is to predefine a number of features that you want to use in your model. Now, after you have decided how many features you want to include, this method fits the model using all features. And then, based on the coefficients or based on the feature importances, the least important feature are eliminated, and then this procedure is recursively repeated on the selected set of features until the desired number of features to select is eventually reached. Okay, so we will also perform an example of this in the Jupyter Notebook. And of course, there are many other methods to select important features in your models, like L1 feature selection, threshold methods, three-phase methods, and all of these you can do in Scikit-Learn. But we will stick with three first that we discussed. And now let's go to the Jupyter Notebook to see how we actually apply these methods in Scikit-Learn. Okay, here we are in the Jupyter Notebook. These are the objects that we are going to import, including the traditional libraries. And here we will use we will use first this credit card default dataset. And in this cell, we are applying the traditional transformations that we do to the raw data. And here I am distinguishing between the dummy features that we have in our dataset and the numerical features, because we will apply different methods depending on the class of feature that we have. Okay, here we apply the scaling operation for feature modeling, and the first method that we talked about in the presentation was removing dummy features with low variance. So we can get the variances from our features using the var method. And then let's see the variances only for the dummy features. Now, as I told you in the presentation, you can choose, for example, a threshold for the variance. So you can say, for example, that you will consider only the dummy features that have a variance over 0.1. In that case, with such threshold of 0.1, the two candidates for elimination are pay 5 and pay 6 in this case. Okay, so this would be the first approach for removing unnecessary features, dummy features with low variance. Okay, now the second approach that we talked about is statistically selecting the features that are related with the target. And we have two cases. This is a classification task, so we have two cases. We have categorical features, which would be the dummy features, and we have the numerical features. Now, first, let's perform the statistical tests in the dummy features. So for performing this statistical test, we are going to import this object, the chi2 squared, from the feature selection submodule in Scikit-Learn. We will also use the select k-best, which is the object that we will use to perform these statistical tests in all of the dummy features. Okay, so we instantiate this object called dummy selector. We pass the statistical test that we want to apply, and here I am passing this argument as k as all, because I want this statistical test to be applied to all the dummy features. After instantiating this object, I run the fit method, and here I have the chi-square scores, and these numbers don't make a lot of sense. But the thing that you have to know about this is that this is a statistical test, and the larger the number, the stronger the relationship between the feature and the target. Now, if you remember your statistics class, this is a hypothesis testing setting, so we can also calculate the p-values, and we can say that the features where the p-value is greater than, say, 0.05, we can say that those features are not related with the target. Now, in this case, as you can see, we get very small p-values for all the features. So this statistical test is telling us that actually there is a relationship between the target and all of the dummy features. So under this methodology, we shouldn't eliminate any of these dummy features. Now, for evaluating the relationship between numerical features and the target, we can use another statistical test called the f-classif, and we use again this object. We pass the statistical test that we want. We pass the number of features that we want to select. In this case, I want the test to be applied to all numerical features, and then I am using the fit method again with the numerical features and the target, and these are the p-values that I get from this application of this statistical test, the F statistical test, and then I can select which of the numerical features have a p-value greater than 0.05, which is the usual threshold for statistical tests. And the results here are that these three features, bill amount 4, bill amount 5, and bill amount 6, these three features are likely be irrelevant or to not be related with the target. Okay, so we have here these three candidates for elimination. Okay, now if you want, you can eliminate these three features, or you can apply some of the techniques that we will see in the future videos of this section in order to deal with these features. Okay, so this was the second technique that we discussed in the presentation, and this is the recursive feature elimination, the third technique. And for this example, we will use the random forest classifier model. Remember that we have here 25 features. Okay, so let's say that we want to select only 12 features. Let's say that we want a model that uses only 12 features, so we are using about half of the features. Then we can use this object from Scikit-Learn, RFE, from feature selection module. We can use this to actually select these 12 features using the recursive feature elimination technique. Okay, so we instantiate this object by passing which is the estimator that we want to use, and the number of features that we want to select. Now, remember that the random forest provides us with a metric of feature importance, so we can actually use this model with this technique of recursive feature elimination. Okay, after using the fit method on the whole dataset, what we get is the selector support. So we get true for the features that included in our model, the 12 that we wanted, and we get false for the ones that should be eliminated. So according to this object and to this method, the 12 most important features that we should include in our random forest model in order to predict the target are these: limit balance, age, pay, all the bill amounts, and pay 1, 2, and 3. Pay amount 1, 2, and 3. And the features that should be eliminated according to this method are these, because they are not very relevant according to this method and to this model to predict the target. So now what we can do is to evaluate, the simpler model, the one with the 12 features, with the full model, the model that we have been using so far. So after, evaluating these, after fitting and evaluating these models, we can calculate the metrics using cross-validation. So we are here in this example, we are using tenfold cross-validation to get an estimation of the performance of these two models. Okay, the one with, remember, this selector model is the one with the 12 best features according to the recursive feature elimination technique, and this is the full model, the model with the 25 features. And these are the results. Look, the full model has a recall of 0.36, and the model which includes only 12 features has a recall of 0.35. Now, it is less here, so in terms of recall, the best model is still the full model. But notice that only using half of the features will give us almost the same performance. So we get almost the same performance. As you can see, the values are really close. Now you can decide as the analyst if you want to use the full model, or if you want to use the simpler model. That is up to you. And in terms of accuracy, as you can see, we get almost the same accuracy. Still a little bit more accuracy with the full model. But now you have a technique to decide if you want to use a more complicated model, a model that uses more features, or you can use a simpler model with these techniques. Okay, so in this video, we learned about some feature selection methods and how to use them in Scikit-Learn.